let's do some scientific notation. You may already know this, but when we're talking about scientific notation, we're talking about an easy way to write numbers that are very, very large or very, very small into a way that's more manageable. And our scientific notation is always written as A times 10 to the n, and A has to be less than 10, greater than or equal to 1. So it has to be a number between 1 and less than 10, and then times 10 to a power. So here's the way you do that. When you have a number and you have a decimal in it, so 7,000 has a decimal at the very end, you want to try and place your decimal to make that number a number between 1 and 10. So if I was going to take my decimal to make 7,000 between 1 and 10, I'd have to move my decimal in between the 7 and that first 0. So I'm going to write that number a little bit larger so you can see actually what I'm doing. So 1, 2, 3. That took 3 hops to get to in between 7 and the first 0. So 7.0 times 10, and I took 3 hops to get there, so it's times 3. When we're moving in scientific notation, if we move our decimal from the right to the left, our exponent is going to be positive. If I have to move my decimal from the left to the right, then my decimal or my exponent is going to be negative. An easier way that I think it is to understand that is if I'm looking at 7,000, 7,000 is a large number, I need a positive exponent. If I'm looking at something like the next one, 0.03, that's a very small number. My exponent on my 3 or my 10 is going to have to be negative. So if I'm looking at 0.03, I'm going to write it larger just so you can see what I'm doing. I would have to move my decimal after the 3 to make this a number between 1 and 10. So 1, 2. That took 2 hops to get there. So this would be 3.0, I'm going to add the 0 after it, times 10. It took 2 hops, and it was a negative 2 because I went to the right. So 3, you could write that as just 3 times 10 to the negative 2. Either answer is correct. Okay, those next two, I don't know why they're the same exact problem. So let's go down to some of these longer numbers. Here we've got 895 million. So let's count and see how many. 1, 2, 3, 4, 5, 6. I need to go between the 8 and the 9. 7, 8. I want 8 hops. So 8.95 times 10 to the positive 8, because that's a very large number. Okay, the next one, I need to go between the 4 and the 5. 1, 2, 3, 4, 5. Took 5 hops, so 4.56 times 10 to the negative 5. Now, 8.5 is already written in scientific notation. It's already between 1 and 10. So if I were going to have to write that one in scientific notation, you could write it 8.5 times 10. And remember, anything raised to the 0 power would be a 1. So 10 to the 0 power. So if you have a number that's written in scientific notation, a times 10 to the n, the number must satisfy the inequality between 1 and 10. And notice it can't be equal to 10, it has to be less than 10. Alright, let's try this 240 million. Then you go between the 2 and the 4. 1, 2, 3, 4, 5, 6, 7, 8. So 2.4 times 10 to the 8. Okay, let's look at the next page. Okay, sometimes I might not just give you a number. I could give you, these can be used in a lot of world situations, a lot of space things, a lot of science experiments when you're dealing with very, very small amounts. You can write in scientific notation. So this is, let's just do 1 or 2 of these because you're not going to encounter just the really large numbers each time. So we'll do this one. I need to come between the 5 and the 9. There's where my target decimal is going to go. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I had to move 12 hops. So 5.9 times 10 to the 12. And then let's come down here to this. Let's do the one that has the grams. I don't think you're going to have one that long in homework. So let's do the one that has the grams. I need to come after the 4. That's where my target date or my target decimal is. So 1, 2, 3, 4, 5, 6. So 4, I'm going to put 0.0, you don't have to, times 10, and we moved 6 spots, and it was really, really small, so it's a negative 6. Alright, so what if, so it says to write a number larger than 10 in scientific notation. Move the decimal to, so larger than 10, that would be these really large numbers. I'm moving the decimal point to the left. If I'm writing a positive number less than 1, that would be like this one that I did in this with this dose of a medicine. In scientific notation, I had to move my decimal to the right. Alright, so we'll just do this last one for kicks. It's going to have to come, the decimal's got to come between the 9 and the 1. So 9.1 times 10, and we know it's going to be negative because this is a really, really, really small number. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. Woo! That was a lot of zeros. Okay, let's do some operations with scientific notation. If I give you a scientific notation number and I ask you to give me the number back in decimal form or without the scientific notation, which way will the decimal need to move? Well, let's think about it this way. If I have 1.384 times 10 to the negative 4, that means I have a negative exponent. I need to make my number smaller. The way you will make your number smaller is to move your decimal to the left. So, and it's telling me to go 4 places. So 1, 2, 3, 4. Now, in the little dips, put zeros. So 0.0001384. So my decimal has now moved over in front of this first 0. Alright, 3.69 times 10 to the 7th. So if I have a positive, if I'm making my number larger, because that's a positive 7, then my decimal to make a number larger needs to go to the right. So 7 places. 1, 2, 3, 4, 5, 6, 7. And then in the little dips, put your zeros. So 3, 6, 9, and then 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5. So if I were to put commas in, look like that, 36,900,000. Alright, 5.892 times 10 to the 0. Remember, 10 to the 0, anything to the 0 power is equal to 1. So that would just be 4.892. Doesn't change at all. Alright, I'm going to skip down here to the bottom of the page where we're going to be working these that are multiplied and divided. We're going to do some of those because sometimes they can be a little tricky. What you need to do is multiply your decimal numbers and then combine powers of 10. And since this is multiplying in this first one, my powers of 10 are going to be added. So the first thing I'm going to do is multiply my decimals. 8.6 times 4.0, that gives me 34.4 times. And when I take my 10 cubed and my 10 to the negative 9, 3 plus a negative 9 gives me negative 6. So 34.4 times 10 to the negative 6. But I have a problem with this one. 34.4 is not in scientific notation. That's not a number between 1 and 10. So I'm going to come down here and I'm going to have to change 34.4 to a number between 1 and 10. And to do that, I have to move my decimal 1 place to the left. So that becomes 3.44 times 10 to the what? I move my decimal to the left, so that's going to be 3.14 times 10 to the 1. I moved it 1 place. So you have to think about it this way. If I multiply 3.44 times 10, that'd be moving it back and making it a 34. Now, let's don't forget, remember at the beginning when I combined my tens, I had a negative 6. So now I have to bring it down. Now I've got 2 more tens to have to combine. So I get 3.44 times 10. 1 plus a negative 6 would be negative 5. That would be the final answer on that one. Okay, here's a division one. Here we're going to divide our decimals, and then we are going to subtract our power of 10 exponents. So 2.25 divided by 5.0 is 0.45, and then 10 to the 8th over 10 squared, 8 minus 2 is 6. Now again, 0.45 is not in scientific notation because that's not between 1 and 10. So 0.45, if I move it one place, I would have 4.5 times 10, and I moved it one place. I moved it to the right. I had a small number, I have a small exponent. So 4.5 times 10 to the negative 1 is the same thing as 0.45. But remember, I had the times 10 to the 6th up here, so I have to put that on there. Now combine these two, so 4.5 times 10 to the negative 1 plus 6 is a positive 5. Those are the trickiest ones. And sometimes you'll divide these out or you'll multiply these numbers out and they come out to be numbers between 1 and 10. It's just if you don't happen to have a number between 1 and 10, I want you to be prepared. Alright, so let's look at these last two. 3.5, I need to take 3.5 times 5.1, that's 17.85, times 10 to 10. I've got to the 4th power, negative 7. 4 plus a negative 7 would be negative 3. But 17.85, I need to make it into 1.785. So I moved it one place, and it was a big number. Well, it was a big number, not huge, but it was larger. So it's times a positive 1 times 10 to the negative 3 that I had in the original problem. So that's going to be 1.785 times 10 to the 1 minus 3 would be negative 2. Alright, last one. 2.16 divided by 6, that gives me 0.36 times 10 to the, you need to subtract the exponents, 9 minus 3 is 6. So again, the 0.36, I need to change that to 3.6, and it was a small number, so it's times 10 to the negative 1, times my 10 to the 6th that I had in the original problem. So 3.6 times 10 to the 5th. And we are done with scientific notation. Have a great day.